So, thanks everyone
Recording.
for coming to today's enterprise conversation. We have with us two individuals from Viriciti. Do you guys want to introduce yourselves?
Yeah, it's Simon, from CTO from Viriciti, a founder, and my colleague Tamme.
Hi, thanks for having us. I work at Viriciti for the last 5 months as a backend developer, and I mainly focus on our API design. So how do we expose our data to the clients and also internally between the services?
Yeah.
Awesome.
Should we go to, do you want to go to the use case, Viriciti?
Yeah. So, well, let's go into your roles first. So what are your roles with the company, within the company? What do you do kind of day to day at Viriciti?
Right. Well, I'd say my main role is to make sure that our business and our architecture remains scalable, flexible, um, is easy to adopt new technologies, and is easy to update, to bug fix, and to scale. Make sure that any competition, any new kid on the block could not compete due to choices that we are currently constantly making. I consider that my role, and with that, I try to address as much people in the organization also thinking about it, especially my all the developers at Viriciti, to let everybody know what is important to Viriciti, and let everybody also come up with great ideas, with new ideas on technology and how to use it, and together we try to make the best moves there, whilst still enabling our customers with new features and extending there. So it's broadening up, bigging up the market that we are in, which is expanding, making sure that we not run into bottlenecks, but at the same time also extend our functionalities to become a way more complete product and a more complete proposition in the business that we work for. And that's for electric vehicles and the operation of them. Tamme, can you elaborate?
Yeah, sure. Like I just said, I am mainly focused on the back end of our services. We have a lot of services, they all expose data. We have our own clients, we have web apps and mobile app. We also would like to expose this data to third-party clients, and my job is wait.
You mentioned the electric vehicles. Could you elaborate a bit on that? Will work.
Won't, I guess. So let's get a bit into use case. So what is eminent, or what everybody knows, is that is cheaper every mile. This is especially interesting for public transport or even trucks. For public transport, it's interesting. You also have defined. You have a more controlled atmosphere where these vehicles are operating in. Although the main drawback is the initial investment. Electric vehicles are way more expensive, especially due to the battery technology, and the amount of energy that you can carry around is way less. So you could say you bought an iPhone 10 with a really bad battery in it, and you need to energy manage that thing during the day if you don't want it to stop working. And even worse, every day your energy consumption can vary due to environmental influences like the weather. If it's colder, you have to turn on your heater. The heater will draw the energy from your battery, but that's the same energy origin where you also need to drive your mouse with. Your routes could change. Could be more. The traffic could be different from day to day. So your energy consumption can differ, and that makes operators not want to transition into sustainable transport like electric vehicles. And this is something we try to resolve. We try to take that drawback away of not knowing when your battery actually depletes in order to transition and to speed up the transition from combustion engines towards electric vehicles. And on one hand, we are supporting the financial incentive there, that it is actually cheaper, the amount of maintenance is lower, the amount of energy costs per mile is lower. So there is a turning point where it becomes more cheap. Although you have to really facilitate this with a really good monitoring system that maybe even talks back to the vehicle and influences the energy consumption in order to maintain the objectives that the vehicle needs to do during that day. And that's also where we try to optimize and save costs. Now, this is all from a vehicle perspective, and vehicles are an energy user. On the other hand, we have a charging infrastructure. If you have 40 vehicles driving around, you also need to charge them. If they all charge at the same time, or if there is a queue in front of the charger, this is all not what you want. Especially energy peaks in the network can be very costly for companies. You have to really pay for that. So also charging, providing the energy to the electric vehicles needs to be a part of the equation that needs to be optimized. So that's basically what Viriciti is all about.
Gotcha. And so how do you kind of help resolve those problems? I assume it's through kind of aggregating that data and then making it available to the people who are buying the electric vehicles.
Sorry, can you repeat?
Yeah. So I was just wondering, like, how you help solve that problem. Are you like aggregating the data about electricity usage and then individual vehicle usage, and then surfacing that to or companies who are using electric vehicles, and you're trying to help solve that problem of understanding these bits of it. Am I right in that?
Yeah. So we have created our own piece of hardware, which is just simply, and you can buy these days this system on a module. It's basically a small computer. It sits on something that looks like a piece of ROM, right? Just like a DIMM, like that. You put it on a PCB, and then you connect the main vehicle data line to it. The main vehicle data line is a bus where all electric components inside the vehicle post whatever they are doing and whatever information they're creating, but they can also subscribe to other data. So it's like one big source of information where electric components can put data on and get data off. So for example, if the accelerator pedal is pushed down, it will be put on the CAN line. And for example, the powertrain sees it and knows, hey, I need to accelerate to a certain speed, and it will do and comply. The battery system, the battery management system, is also connected to this CAN line. So he posts data there about all the currents that are flowing through all the modules and the cells and all the temperatures and all the voltages. And all of that information is available. So we connect to this line. It is behind the firewall, so we mostly connect it to a diagnostics line, as it's called. And all of this data, it's like 1,200, 1,800 messages per second, is being streamed to our cloud. Of course, we do a few optimizations there, but there is an active uplink between the vehicle and our cloud system, where every vehicle has its own little state process. And there, the CAN data, as it's called, is byte data as it is coming in. We transform that to actually engineering units so you can understand them. But because they're in the cloud, they're basically a real-time representation of what that vehicle is currently doing. Is it driving? Are the doors open, closed? What's the temperature? What's the RPM? What's the GPS location? And all the battery and the currents and the voltages. So every time something changes, whenever there's a new data in the CAN line, on the CAN line, or it actually changed, we can send over this data. This ties very close together with choosing Node.js as an event-driven platform. So when this uplink is always maintained and it's always connected to its state process. So if you'd have 40 vehicles, you'd have 40 state processes, and they could all publish their data as well. Now, if I want to make a web interface that, for example, follows this vehicle and all the parameters that come off of them, I just build a small microservice based on Node.js. I'll make sure that it can respond to WebSocket requests. So we'll have an active connection from the browser to that service. And that service, for example, gets the request, hey, follow this vehicle. So within our framework, it will find the vehicle. It will subscribe to the data that, for example, your map view needs, the GPS data, the state of charge, and maybe some other data like errors and warnings. And instantly a real-time flow is established between what that vehicle is currently doing and what you're seeing in the browser. Now, this is a real-time feature, which is great and it's nice, but you want to be able to act upon it. So we have other services that request, for example, estimated range from these kind of state processes. And if estimated range goes beneath a certain threshold for that route, we can trigger an alert to anyone, to an operator, or send an SMS, or that kind of stuff. But we can do more. We can do computations in other processes, and the outcomes of that could go back to the vehicle, and that could be written to the CAN line again to influence, for example, the driver dashboard, to show the driver how he's currently behaving, or if he should charge, or if he should maybe even skip a charge because he is late on his schedule.
Awesome. I think that really goes well into the next kind of topic we want to discuss about, which is, you know, your use of Node. And so it does seem like you're using that to kind of aggregate the data, or, you know, process the data and then show it to, you know, the end user, the person who's, you know, a controller of this fleet of vehicles. So yeah, I'd definitely, you know, be interested more in, you know, the specific use case you have. And like, you know, you mentioned microservices, and you mentioned, you know, a web dashboard. I'm curious to kind of know a bit more about that implementation and your usage.
Right, yeah, so as I just explained, I really talked about a real-time component of our complete framework. I talked about hardware on vehicles, which is a problem of its own, right? If I just may take this side road, if you let me, hardware,
yeah, absolutely,
is as unsecure as it is, right? I don't know if you know Resin.io. It is it's basically a platform that ties together with the Docker layer, and basically what you could do is you can make a small process that continuously checks if the right software is, for example, running on your vehicle. what happens with this is that, and this is all, of course, Node.js. With this, you can and this is all, of course, Node.js. With this, you can always, aftermarket, after your sale has been done, update your applications, make them better, make them bug-free, or maybe add a feature in the future. Maybe you haven't realized yet that you want to also control or connect to some kind of machinery in the vehicle. You can later do that because you're using basically something with a Docker layer and the containers that are running in it and a small process that controls that. But also the operating system itself needs to be updated. So when you create so as we call it, the data hub, we also saw that the microservices kind of approach is not just for frameworks and not just for server parks or Kubernetes stacks, but also for basically hardware inside a vehicle. And that's a pretty nice approach for us. So we can always be more extensible and more secure than the competition. So this is hardware side. Where were we going? Yeah, so I already explained you the real timeness of part of a framework. Obviously, we are also on the fly doing analysis and also aggregate that data into our MongoDB database servers. And this is where you can, for example, if you have a feature like download all your reports, like what asset has been underperforming with, for example, a kilowatt hour usage that's per mile, that's like lower than a certain threshold, or you want to, well, basically you have a source of the accelerometer that's on our hardware. You can also say, what is the worst driver that I have and how can I help him improve his driving behaviors? Because as you know, driving electrically is not just about the way you cruise or the way you accelerate, but also if you do regenerative braking. But we can access that through the same data source, so that's nice. So a reporting tool is out there, but also exports. Currently we do that serverless. So if you want to download wherever your vehicle has been and what all the error codes were and what your battery has been doing over time, you'll need a lot of time series data, which we manage through the serverless part. Yeah, this is all kinds of things how you can, for example, make reports and see where your operation is actually going.
That's super awesome.
At the same time, we are also tapping into live feeds like route information, route changes, of course, also over time. Where is the vehicle on the route? What is the current schedule for this vehicle today? Is the driver behavior influencing, or is it creating any? I wouldn't say sweet spots, but basically in the charging strategy, is it still compliant with how the energy drainage of this vehicle is currently going? Those are all questions that we try to answer for our customers.
Awesome. And so I think that kind of some of the bits from each of these discussions kind of lead into the next topic, which is why did you choose Node? Deploying it with Docker onto IoT devices, and then using it in the cloud to kind of manage and process and output data, and then even using it in the serverless space. I'm curious, what the decision was behind choosing Node and what led you to the path of Node. And you kind of mentioned it with the event-driven model. But yeah, I'm curious to kind of get your insight and input on that.
Yeah, exactly. So before using Node, I was a PHP developer. But when starting this company, we could think of at least new tools and something that would be that seemed like extensible. And at that time, you had Node Node.10, I believe. Yeah, that's 5 years ago.
Oh wow, yeah, you've been around a while.
So, but the event drivenness and the non-IO blocking promises, but especially the event drivenness was key for us. We had no clue how much data we would go and process, but we wanted to be extensible at the same time. I mean, we could have chosen Java, but I don't think we could have had and maintained the fast iteration cycles and reduction of complexity. Node.js just provides you the tools to prototype really, really fast, but that was during the prototyping stage. It turned out that in production it would even scale well as well. So we never had any regrets on choosing Node.js.
That's awesome.
Yeah.
One of the things I'm interested in is you said you started around Node 10, which was I think 3-4 years ago at this point, maybe 5 up to 5. Back then, were you thinking about doing the IoT side of it, or were you doing the IoT side of it with Node, or was that kind of a down the line decision that, oh hey, this also works here?
No, we didn't consider it, although at that point, well, actually we did. Node.js was our choice and was our go-to language. Also for the hardware side, at that moment we didn't have any funding or whatsoever, so we had to do off-the-shelf vehicle computers that would just run Ubuntu Linux or something. That's what I would supply them with, and then they would run a small Node.js program to handle all these scan messages and to stream them to the cloud. And we just didn't know how CPU intensive it was going to get, but we knew it at that moment. The design of our hardware was not modular. It was not really extensible. We had no good ways to update the operating system. That basically could lead to really big problems in terms of scaling. But we just wanted to make a really small Node.js program. We wanted to be streaming as well. We found the streaming API very important argument as well for doing that part of the job at that time.
That's awesome. And then again, that kind of leads into the next topic, which is, how has Node, helped your business grow, and like what have been the benefits to the actual business side of the company, in terms of growth and success?
Mm-hmm. Yeah, that's a good question. I think versatility, the amazing amount of modules that are out there. You want to use a GPU. Oh yeah, I forgot to mention. What was also really important for us was connecting to hardware, connecting to serial ports, connecting to GPS devices, using the modules that are out there. They also basically compile to your architecture, and being able to get that information straight into your V8 virtual machine was also really awesome, and also a big reason for our choice for Node.js on the hardware side. But basically for the rest of our framework, how did it help impact our business? We were always able, but it also ties a little bit with the choice of microservices. We were always able to migrate or to shift towards where we wanted to be, where we could always make changes, make small changes and make them fast by basically changing our Node.js script. And the adoption of our new employees was also super fast in that sense. So we do a lot of internal training to get young enthusiastic guys from university to really work in a project where you have to put Node.js to the test, put it actually in production, and actually needs to work there. So I'd say it for example, half a year ago, I decided we also had to do charge stations. So monitoring them, making a scalable framework for the charge station side with all their messaging and all the commands that you have to send back and stuff, protocols that you have to implement. And with the knowledge that we have and the tool set and Node.js, we were able to kick this off to a full-fledged production tool for different stakeholders, and it runs and it scales. It's amazing. People that were used to other back offices for charge stations didn't know what they saw. They saw real-time things happening in their browser. They saw messages coming in. They saw errors coming in. And that currently gives us a very good upside in terms of the competition.
That's super awesome.
Yeah,
cool.
Super happy.
Great. And so, final thing I'd kind of like to talk about, what's next for your use of Node.js? Where are you going with this? This doesn't necessarily have to be technical. It could be, engaging with more developers, contributing to the ecosystem, coming to more events. I'm just curious, what's next for your usage of Node?
Well, currently in Viriciti, we're working on improving our API. Like we mentioned before, we have a lot of microservices. They all need to expose their data to the outside world. We just launched a new domain with the charge stations, and it was time that we got our own API gateway. And well, everybody that uses Node knows Express, and there's actually a really cool new project, relatively new. It's called Express Gateway, and we investigated it. And basically what it does is that Express Gateway provides you the perfect tools to create your own API gateway in Node.js. It's a thin layer on top of Express.js. And for example, for the new domain, the charge station domain, we build our own API gateway in Node.js using Express Gateway. And you can completely customize it, much like you write middleware in Express. The gateway entities, so like pipelines and plugins that you use to customize the internal logic, these are just wrappers around Express middleware. So we were able to use our in-house knowledge, and even sometimes already modules we had, we could incorporate them in this new gateway, and we're right now in production with a fully functional API gateway that have written in Node.js, and I think that's really cool. I think that's really awesome.
It's awesome.
Yeah, that's super. Other thing, so the device manager that we currently have that allows you to update and upgrade and add to remote devices, considering apps. Basically, based on the idea of Resin.io, we are currently in the process of open sourcing it. Mostly because we have two sister companies that would love to use it.
Yeah.
But also as a nice first attempt and trial to see how open sourcing works. We have a few modules open sourced, but if you don't know what they're used for or how to use it, they don't really get traction in the NPM infrastructure. So we're currently also looking into more open sourcing or these kind of products and see how that goes.
I think that's also a big strength of using Node.js. It's like the whole module ecosystem around it. NPM is amazing to work with, and also if you want to open source your own or use other, it's amazing.
We use a library for our Kafka messaging, RD Kafka. And it's so easy to just add to it, contribute, and also file issues. And it's been picked up. Quite amazing. What we're currently doing with Node.js is pipelining all the data that we have into our machine learning models. We are now also training models to even better distinguish all the attributes of what an energy usage of a vehicle actually is composed of, and how to sort of take them apart, being able to, with the weather forecast and what driver is driving, even predict better what will happen on a day. Especially currently when, for example, sometimes the temperature just drops. For example, last winter we had a bad winter, and then at some point it got really cold.
Mhm.
And then you saw the energy consumption of vehicles go up, and there were problems with some of these electric operations of municipalities. We're really having trouble there. So we need to also incorporate our machine learning way more to also compensate for that. But yeah, that tool Node.js helps there. Yeah.
Sorry, I was going to say, I'm curious what kind of platform or tooling you're using for machine learning with your your data.
So in the end, it will go through TensorFlow.
Okay, cool, awesome.
Yeah,
cool,
works.
And I think with that we can probably wrap up. Anything else you guys would like to add?
No.
Okay.
Thanks for having us. Now, talk about it.
Yeah.
Thanks for coming on. Appreciate it, and we will hopefully see you again soon. Bye.
Yeah, great.